Okay, let's see. This is that we're going to use the formula Q is 2 pi resonant frequency energy stored over power dissipated. Okay, the rate at which we lose the energy. Okay, so let's see. Energy stored is going to be the initial stored energy here, right? Okay, so we're going to use the total energy is 1/2 m omega squared x naught squared. So let's do that. That's the first thing, right? So 1/2, our mass is 2.8, right? Our omega is 2 pi over 8.4, and that's squared, right? And our x naught is 1.3. Okay, so let's figure this out. So 0.5 times 2.8 times parenthesis 2 pi divided by 8.4 times 1.3 squared. And I'm getting 1.32. The initial energy is 1.324 joules, right? So we got the first answer, right? Okay. So then what is its Q value, right? So it's losing rate energy at this rate. Now we can use the fancy formula here, right? So Q is 2 pi. Our resonant frequency is 1 over 8.40. Okay, I'm getting that because what frequency is 1 over period, right? Okay, and they give us the period. So it's 2 pi, 1 over that, right? Energy stored is 1.324 joules. And it's dissipating energy at a rate of 0.275, and that's joules per second. Remember, a watt is a joule per second, right? So notice the units on this, joules cancel, right? And we've got 1 over seconds. It's going to be canceled by 1 over seconds, which works out, right? The Q shouldn't have any units. Let's see what the Q ends up being. Okay, so 2 pi times 1 divided by 8.4 times the answer I just got divided by 0.275. I'm getting 3.6. Q is 3.6. And there are no units for Q.